And also I can use the MS Teams. This is called as the multitasking. CPU carries out more than the one task at the same time, and the processor switches between the task. It completes part of the one task, then switches to do the part of the another task. This process happens very fast, but it appears that the tasks are happening concurrently. So the processor will switches from task to task, but for our eyes it will appears as the task are parallelly running. Running parallelly like that, it will appears to our eyes. So true multitasking requires more than the one processor. So many current CPUs have the multiple processing cores. Okay. And then interactive operating system. So direct interaction. So while a program is running, for example, it accepts and responds to the input from the user, and question and answer between the user and the computer. For example, whenever I want to try or whenever I want to purchase from a but online website, it will directly, it is an interactive one. So question and answer session. So how many units you want, according to that it will calculate the amount, and it will ask you to and direct you to pay the amount like that. Okay, if your PIN number or some if you are not having any balance, it won't allow you to submit the button. So that is the interactive operating system. So computer that gives you an immediate response is called as the interactive system. So interactive processing, for example, these are all some of the interactive processing: booking concert tickets, ordering books online, and handling bank accounts. So these are all some of the examples for the interactive processing. And the real-time operating system. Real-time is the must response to the events with no discernible delay. So what do you mean by discernible delay, students? So what do you mean by no discernible delay? Hello? No idea. So discernible delay is nothing but without but even a single delay or a very second delay. So we can say it must respond to the events with no discernible delay. It responds immediately to the data entered. So this type of operating systems required. So where the response time by the system is very critical. For example, it is but used for the control systems. For example, traffic lights and air traffic control and aircraft navigation. These are all the situations where we need the immediate response from the operating system. So that is called as the no discernible delay. Okay, so this type of operating systems are coming under the real-time operating systems. So these are some of the examples. And the batch processing. So data can be collected but over a period of time, and when all data collected, it is processed at the same time. So batch processing, by the name itself we know, by batch it will be processed. So data is processed at an off-peak period. When the CPU is not very busy, at that time only it will be processed. So when there is very less demand on the processor, and also very less disturbance to the daily work schedule, and also the system and the peripherals available when most needed. So it does not need any staff intervention. It will automatically process. So in a batch by batch systems. The distributed systems, it is a very complex task. So here in the type of distributed operating system, so a very complex task is split into a number of smaller and the similar tasks. So a series of computers connected together via a network. So computers can be in different physical locations. So each computer performs the part of the processing. For example, so film animation and modeling real world scenarios. So these are all some of the examples for the distributed system. distributed system is nothing but a very complex task is divided into number of small tasks, and these number of small tasks are parallelly executed in the various computers which were located in the different locations, and they will combine the task and put it into the only one task. These are all some of the types of operating systems. Okay, so from first single user and multi-user, multitasking, interactive, then real time, and the batch processing and the distributed systems. So till now, so any doubts, students?
Ma'am, could you please explain the distributed system?
Okay, distributed systems. Okay. So distributed systems are nothing but, so here a very complex task is split into a number of very smaller tasks. Okay. So here these smaller tasks are executed in a different computer systems which were located in a different locations. For example, imagine some manufacturing industry and all. Okay, so in the manufacturing industry, we have so many departments. Okay, so
Yes,
for
ma'am.
example, marketing department and accounts department, purchase department, and quality checking department. So like that, we have so many types of department. So they will coordinate the processes. So they will divide the task into the different types. For example, if suppose any customer is ordering for some products in that manufacturing plant, they will divide the task into different. So first they have that customer has to approach the purchase department. Okay. So sorry. First they will approach the marketing department. So marketing people will communicate to the purchase department according to the requirement of the customer. So they have to communicate to the purchase department. So according to the requirement, the purchase department will buy the raw materials from outside, and they will communicate this to the manufacturing department. And after manufacturing all things, this product will be checked by the quality department, and then only it will also go to the dispatch department. No, so here this complex task is divided into so many little tasks, and it will be processed in different computers, and when it is dispatched to the customer, it will be combined into a single output and dispatched to the customer. So that's what I am telling here. Like that, so here in the film animation and all, so they will divide the task into different little tasks, and do the execution in the single parallel computers, and combine the animation into a single film. For example, if you see the Avatar film, no? But Avatar film, I hope lot of animations are there. Yes. So like that, in that movie, it may be a chance for the distributed systems. So they will, each and every frame will be executed in different computers, and they will combine into a single cinema. But are you able to understand?
Yes, ma'am. Yes, ma'am. I understand.
So any other doubts in this? Okay, shall we pass on to the next topic, students?
Sure, ma'am.
Okay. So next is students, whether the screen is visible to you now?
Yes, ma'am. Yes, ma'am.
Okay.
Yes,
So
ma'am.
next our topic is processes. So what do you mean by a process, students? Process means what?
Something happening, ma'am.
something happening. Yes.
Yes, ma'am.
So,
Program
so
learning,
process is
like
nothing but under execution. So something is happening at present is called as processes. Okay. So here that we will discuss these types. So these topics. What do you mean by process concept and scheduling and operations on processes and inter-process communication and also examples of inter-process communication and communication in the client-server systems. Okay. But an operating system executes a variety of programs. Yes, of course, it is so executing a variety of programs. The first one is the batch systems and the time shared systems. Batch systems is nothing but, as I say already, they will collect several jobs into a single batch and that batch by batch it will execute. And the time shared systems is nothing but so user programs or task. Some time will be scheduled for each and so every program and then only it will be executed with the help of an operating system. That is called as the time shared systems. For each and every process, some time allocation will be there and within that time allocation that the process should be executed. Okay, so here a process is a program in execution. Okay, so process process execution must progress in the sequential fashion. Process is nothing but a program in execution in a sequential fashion. So step by step only. When we are so writing a code in a Java or basic or so any type of language, so in the sequential fashion only, by step by the first line will be executed and the second line, third line, like that only it will be executed. So that is called as the sequential fashion. So a program will always be so executed in a sequential fashion. So each and every process so comprises this program counter, stack and the data section. Okay, so these are all the parts of or components of a process. So program counter, stack and the data section. So this is a so pictorial representation for a process in the memory. So stack will be there and the heap. So memory will be there, heap memory will be there, and the data is there, and the text is there. Students, can you tell me what do you mean by a stack and the heap memory? What is the difference between a stack and the heap memory?
Stack means lost in, first out.
So that's so characteristic of a stack. And why do we need stack and why do we need the heap memory? So what's the purpose? So anybody else?
Data in the sequential manner. Spread the data in characters like text data into separate. Spread the data.
One second.
To arrange data in a sequential manner, ma'am, like structural manner.
In a structural manner, okay. So that's a stack.
Hello?
So what are you explaining? Is a stack or a heap memory?
Heap is a dynamic memory allocation.
Very good. Okay, dynamic memory allocation for? Yes, good. So stack and so heap are both of the memories. Here, as so one of the students said, so in the stack we can store the data. So what all the so during the process execution, that particularly that process execution, that process will be happen in the dynamic space, that is the heap memory. Okay, the process execution will be happened in the heap memory and the intermediate data will be stored in the stack. Okay, and the permanent data or a local variables or so whatever may be, that will be stored in the data so data space, and what all the text will be stored in the text. Students, are you but able to catch this so concept? So heap space will be utilized by the process for the execution So this will be differ for so each and every process. Okay. And stack, what are all the intermediate data? For example, if I want to multiply 3 numbers or the 4 numbers, first I will multiply 2 numbers and 3 and then 4. That intermediate data will be stored in the stack. Okay. And the permanent data will be stored in a data. So whatever data which won't be but altered will be stored in the data section, and the text will be stored in the text section. But I hope you but understand this so picture, this figure. Students, are you?
Yes,
Yes,
ma'am.
ma'am.
Yes?
Yes, ma'am.
So that you has to know the difference between a stack and the heap memory. So these are all very basics of but operating system. So these are all some of the states of the operating process. So here as a process executes, it changes its states like this new, running, waiting, and so ready and terminated. So these are all the states: new, running, waiting, ready, and terminated. So new is nothing but the process is a new process, and running is so instructions are so being executed, and waiting is the process is waiting for some event to occur, and ready, the process is waiting to be assigned to a processor. So there is a slight difference between a waiting and a ready. Okay, so waiting is nothing but the process is waiting for some event to occur, and ready is it will wait for the processor for the but allocation of the processor. And termination, so by name itself we know the process has so finished its execution. So these are all the states of a process. So this is a pictorial representation. So for the process states, so whenever a process is created, it will be ready for the execution. Okay. So here, so ready means at each time it will be go to the running state, and it will so terminate the process. And if suppose some interrupts are coming means the running state process will be but again so coming to the ready state. Okay. So whenever an interrupt is coming during the running of the process, so again this process will be coming to the ready state. And what do you mean by waiting? So during the running process, if suppose whenever we are if suppose I am typing on so text or some para in the Word document, at that time I want to so print some other document at the same time parallelly. So at that time the processor will so give its focus for the printing only, not for the typing. But isn't it or not? I am having 2 Word documents. So in the first document I am typing one paragraph, and in the second document I want to print the second document. At that time the processor will so give its time to the printing or the typing. Hello?
Printing, ma'am.
Printing
Yeah,
only.
ma'am.
At that so that's what so some other so whenever the processor so giving its time for the printer, at that time the typing document will be waiting for the processor, no? That is called as the waiting process. So again it will so go to the ready state. For that printing it will be wait for the printing or but IO or so that's what I so told you. Waiting is nothing but the process is waiting for some event to occur. Okay, so for the completion up to printing that a typing document will so wait, and then only it will be but again go to the running state and it will terminate. So these are all some of the process states. Students, so any doubts in this process states?
Nothing, go, ma'am.
Okay.
No, ma'am.
So have it in mind: new, ready, running, waiting, and termination. Process control process. So information associated with each processes are process state and program counter and CPU registers and CPU scheduling information, memory management information, accounting information, IO status information. So these are all the details of so each and every processes stored in the process control block. If suppose for so each and every citizen we have this name, and this Aadhaar card ID, and also we have a PAN number. And so what are all the IDs we have? So we have a mobile number, and we have a car. If suppose if we are having a 2-wheeler or a 4-wheeler, we have that number. So like that, here, so each and every process will have these type of information, and this will be stored in a process control block. Okay. So how these processes are scheduling? So in a computer, so many processes are coming and also executing with the help of the operating system or with the help of a processor. So how these processes are scheduling? So there should be a scheduling in a process execution now. So for that we have some types of the queues. So job queue and the ready queue and the device queue. What do you mean by a job queue is set of all processes in the system is called as a job queue. And the ready queue is set of all processes residing in the main memory, ready and waiting to execute. So they will be ready in the main memory and they will so wait for the processor allocation time. That is called as the ready queue and the device queues. So device queues are nothing but set of all processor waiting for an IO device. So processes migrate among the various queues. So a process in a job queue may coming to the ready queue, and so a process in a ready queue may come to the device queue. So like that they will migrate among the various queues. So we have 3 types of queues: job queues and the ready queues and the device queues. And schedulers. So how these processes are scheduled with the help of schedulers. So we have 2 types of schedulers. So long-term scheduler and the short-term scheduler. Long-term scheduler is nothing but it selects which processes should be brought into the ready queue. Okay. And short-term scheduler, it selects which process should be executed next and allocates the CPU. Students, I hope you make the difference between the short-term scheduler and the long-term scheduler. Short-term scheduler is nothing but it will allocate the CPU, and also it will so select which process to be executed next. Okay, so short-term scheduler will allocate the CPU for the processes, and here the long-term scheduler will make the process to so keep in or so stand in a queue. Students, but understandable to you? But I hope you understand.
It will be a large number. It has some large number of data, so that's why it will be less than schedule for the long term. Right?
Yes, yes. And also we have the medium term scheduler is there. So here, so this is the ready queue. As I said, so it will wait for the CPU time, and once it executes, it will be come to the end state. So this is the waiting state now, as we saw, but already in the states of the processes. And here, so whenever in between, so whenever a process is so swap out, it will, but again partially executed and swapped out of the processes. It will be swapping in the ready queue. This is called as the medium term scheduler. So, so medium term scheduler is nothing but the swapped out processes will be, but again swapped in the ready queue with the help of the medium term scheduler. So here processes can be described as so either IO bound process or CPU bound processes. IO bound processor, it spends more time on so doing the IO than the computation. And the CPU bound process, it spends so more time doing the computations. Okay. And so there are so there are many concepts in our operating system. So be attentive to the classes. Okay. So till now we have seen so the definitions are, we have seen very small definitions in a very large so very large numbers now. So what do you mean by operating system, and so why do we need operating system, and what are the types of operating system, and what do you mean by a process, and what do you mean by a process control block, and what do you mean by schedulers, this short time scheduler and a long time scheduler, so like that, and a medium scheduler, and also This is about IO bound process and the CPU bound process and the context switch. And then you should so sit and study, then only these concepts will be understandable. Okay, otherwise it will be very confusable to you. So context switch. So when CPU switches to another process, the system must save the status of the old process and so load the saved state for the new process via context switch. So context switch is nothing but whenever a CPU switches from a one process to the next process, it is called as a context switch. Okay. And process creation. So under the process creation, we have two types of processes. First one is parent process and the next one is the child process. So here, but always the parent will create the child process and the child process in turn create some other child process which will so forms a tree of processes. So generally process identified and managed via a process identifier. So each and every process will have a process identifier, and how these so resources are sharing between the parents and the child are so this is the one type of sharing of resources. So both the parent and the child will be share all the resources, and sometimes children that share the subset of the parents resources, and sometimes parent and the child will be share that no resources will be shared by parent and the child. So these are all some of the cases for the resource sharing. So sometimes so both the parent and the child will share the resources, sometimes they won't share the resources, and sometimes the children only share the subset of the parents resources. And also the execution, under the execution, parent and the children can but parallelly execute, and the parent waits until the children terminate. Until or otherwise, the children processes will be terminated first, then only the parent will be terminated. Okay. So these are all some of the basic concepts. Okay. So inter-process communication is nothing but processes within a system may be independent or the cooperating. Okay. A process may be independent or a cooperating processes. So cooperating process can affect but or be affected by but other processes, including sharing data. Okay, cooperating processes are nothing but they will that so share the resources and whatever may be the communication, they will communicate with the other processes. What are the reasons for cooperating process or inter-process communication is so during this inter-process communication, information will be shared and the computation speed up and modularity and for the convenience. So these are all the reasons for inter-process communication and cooperating processes that need inter-process communication. So for this type of advantages, so they will so share the information and the computation speed up will be increased and modularity. They will so divide the task and for the convenience. And there are two models of inter-process communication. The first one is the shared memory and the second one is the message passing. Okay, inter-process communication is nothing but communication between the two or so more processes. The two models of IPC is shared memory and the message passing. And so this is the shared memory and message passing. So here the process A and process B, so both the process are sharing this so single memory. This is the memory which will be shared by so both the process A and the process B. So here this is the shared memory model and this is the communication model. So message passing model. Here the process A will be communicate the message to the kernel, and in turn the kernel will so pass the message to the process B. So what do you mean by a kernel? So in operating system, students, what do you mean by a kernel?
Core part of the OS. Core part of the OS.
Yes. So core part of the operating system. So the kernel will come the controller of the operating system. It's a main part and it's a core part. So here in the message passing model, the process A will communicate the message to the kernel, and in turn the kernel will pass the message to the process B. So these are all the two models of inter-process communication. The first one is the shared memory. So this is the shared memory, and this is the message passing model. And cooperating, so again the same concept only. And so synchronization. So synchronization is nothing but message passing may be so either blocking or the non-blocking. Blocking is considered as the synchronous, and non-blocking is considered as the asynchronous. Blocking, so what do you mean by synchronous is nothing but whenever a sender send a message to a receiver, until or otherwise it will get the acknowledge, it won't send the next message to the receiver. That is called as the synchronous. Okay. So whenever a sender send a message to a receiver, it has to get the acknowledge. But after getting the acknowledge only, it will send the second message to the receiver. That is called as the synchronous. And what do you mean by asynchronous is, if it won't get the acknowledge, it won't send the message also. It will, the blocking, the sending will be blocked here. So that is called as the blocking. Here, not do you mean by asynchronous is, the sender will send a message to the receiver. So whether the sender is receiving the acknowledgement or not, it will continuously send the message to the receiver. That is called as the asynchronous. Students, are you able to understand the synchronous and the asynchronous? Here in the synchronous, the sender will receive the acknowledgement, but here it won't wait for the acknowledgement, it will continuously send the messages. Okay. So these are all coming under the processes. So small definitions only. Okay. Process, systems, and so what do you mean by a process in the memory, and the process state, and process control block, and scheduling queues, and schedulers, and context switch, and process creation, and termination, inter-process communication. So these are all coming under the processes. So I am going to the next topic. Students, the screen is visible to you. CPU scheduling.
Yes, ma'am.
Yes, ma'am. Okay.
Class name class matram.
Ma'am,
Yes.
PPT எல்லாம் ஷேர் பண்ண முடியுமா மேம்?
எஸ்பா, உங்களுக்கு நாங்க கிளாஸ் முடிஞ்சோடனே ஷேர் பண்ணுவேன் ஃபுல்லா at the end of the day. Okay.
ஓகே மேம், தேங்க்யூ மேம்.
இல்லாட்டி உங்களுக்கு இப்பயே வேணுமா, அன்னன்னைக்கே வேணுமா?
வாட்ஸ்அப்ல ஷேர் பண்ணுங்க மேம்.
ஷேர் நான் ஷேர் பண்றேன். இல்ல உங்களுக்கு இப்ப இன்னைக்கு கிளாஸ் முடிஞ்சு வேணும்னாலும் நான் ஷேர் பண்றேன்.
Yes, ma'am. We
Ah,
need
ma'am.
to understand.
So it will be better
To understand.
Okay. சரி, ஓகே, நான் இன்னைக்கே ஷேர் பண்றேன்.
Thank you.
தேங்க்யூ மேம்.
ஓகே. So CPU scheduling
மேம் எக்ஸாம் ஆன்லைனா ஆஃப்லைனா மேம்?
ஆன்லைன் தான். ஸோ நான் உங்களுக்கு லாஸ்ட் ஒரு 5 to 10 minutes தரேன். அப்போ இந்த மாதிரி கொஸ்டின்ஸ் கேளுங்கப்பா. நான் ஐ வில் கம்ப்ளீட் த சிலபஸ். ஓகே.
ஓகே மேம்.
ஸோ CPU scheduler. Yes. So what do you mean by CPU scheduling is one of the very important concept in operating system. How the CPU is scheduling the main memory or the processor to the process. So it selects from among the processes in the memory that are so ready to execute and allocates the CPU to one of them. Here, the CPU will so select the processes in a ready queue and allocate the memory to the or allocate the CPU to the particular process. So CPU scheduling decisions may take place. So then a process switches from running to waiting state and switches from running to ready state and switches from waiting to ready state and terminates. Okay, the CPU scheduling decisions may take place. Then a process will change from running to waiting to ready, and waiting to ready and terminates. This non-preemptive and preemptive and all I will tell you in the further slides. Okay. Dispatcher. So dispatcher module will gives control of the CPU to the process selected by the short-term scheduler. So in the previous PDF we saw this short-term scheduler and the long-term scheduler. So dispatcher module will gives the control of the CPU to the process selected by the short-term scheduler. This involves taking context and switching to the user mode and jumping to the proper location.
அவன் எதுவுமே கேட்கல, நான் சொல்லுவதும் கூட கேட்கல. டிராப் எங்கன்னு கேட்டான், பல்லாரும் போன் வரேன்னு சொல்லிட்டு போன் வச்சுட்டான். இன்னொருத்தர் புக் இருக்கு அவன்.
ஸ்டூடெண்ட்ஸ் நீங்க வீட்ல பேசும்போது அந்த உங்களோட மைக்கை மியூட் பண்ணிட்டு கூட பேசணும்னு தெரியாதாமா? நீங்க உங்களோட மைக்கை மியூட்ல போட்டு வைங்க. இப்ப என்ன நெசசிட்டி உங்களுக்கு வந்து ஆன்ல போடுறதுக்கு? மத்தவங்களுக்கு டிஸ்டர்பன்ஸ் ஆகுதுல்ல? So scheduling criteria. So how the CPU will select a process for allocating the CPU. So some criteria should be there, no? So CPU utilization and throughput and the turnaround time and the waiting time and the response time. For example, scheduling criteria and pathina, whenever we are allocating seats, for example, in our Anna University, whenever we are doing the counseling, at first they will display the ranking status of the students. Okay. But after completing the +2, the students will apply for the BE in Anna University, and according to some criteria, they will select the students and display the ranking of the students according to some criteria. Like that, here, so how the process or the scheduling criteria will be done? Yes. So CPU utilization and the throughput and the turnaround time and the waiting time and the response time. What do you mean by CPU utilization is, it will keep the CPU but as busy as possible. The scheduling should be, keep the CPU, should not waste the CPU time. And the throughput, the number of processes that complete their execution per time unit. The number of processes should be more, in a particular time, per time unit. Okay. And the turnaround time, the amount of time to execute a particular process is called as the turnaround time. The amount of time to execute a particular process is called as the turnaround time. And waiting time is the amount of time a process has been waiting in the ready queue is called as the waiting time. The time, waiting in a process, the ready queue is called as the waiting time, and the response time is amount of time it takes from when a request was submitted until the first response is produced. Response is nothing but whenever it puts a request, it should be responded. So CPU utilization, throughput, turnaround time. So now you tell me, students, the CPU utilization should be maximum or the minimum?
Maximum.
Maximum. Yes, good. The maximum should be, the CPU should be utilized. What about the throughput time? This throughput criteria?
Maybe minimum.
The number of processes that complete their execution per unit time. அது maximum இருக்குமா minimum இருக்குமா?
Minimum.
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 Huh?
Minimum.
Is it right?
It should be maximum.
It should be maximum.
So that in a short time they can complete more work.
Yes, we can complete the more number of processes. So it should be maximum. So புரியுதா students? The CPU utilization maximum இருக்கணும், throughput உங்களுக்கு maximum இருக்கணும். For example, இப்போ நம்ம பேங்க்ல வந்து கேஷுக்கு நிக்கிறோம்னு வச்சுங்களேன், இல்லாட்டி நம்ம டிக்கெட் கவுண்டர்ல நிக்கிறோம்னு வச்சுங்க. இப்ப அதாவது 2 டிக்கெட் கவுண்டர் இருக்கு. சோ ஒரு டிக்கெட் இஷ்யூ வந்து கடகடன்னு கொடுத்தாருன்னா எல்லாரும் அங்கதானே போவோம். ஒருத்தர் ரொம்ப லேட் பண்ணா என்ன பண்ணுவோம், அங்க உள்ளவங்க இங்க வந்துருவாங்க, அப்படிதானே நம்ம ரயில்வே டிக்கெட் வாங்கும் போது. So the number of processes should be maximum. Okay, the throughput should be maximum. The turnaround time எப்படி இருக்கணும், அந்த இது வந்து எக்ஸ்பிளனேஷன் வச்சு சொல்லுங்க. amount of time to execute a particular processes. Turnaround time should be
minimum.
Yes, minimum. It should take only a very less amount of time. And waiting time?
It should also minimum.
Minimum.
So it should be minimum. And the response time?
Minimum, quickly.
So it should be also minimum. So these are all the scheduling criteria. According to these criteria, the scheduling process will be selected by the CPU. Okay. So CPU utilization should be maximum, and so throughput should be maximum, and the turnaround time should be minimum, and the waiting time and the response time should be minimum. So that's what so we are telling here. And here, so these are some of the important concepts, students. Please so be attentive. Here we have 6 types of scheduling algorithms. Okay, for the CPU scheduling algorithms, we have totally 6 types of CPU scheduling algorithms. First one is the first come and first served scheduling. That is the FCFS. உங்களுக்கு இது क्वेश्चन பேப்பர்ல வெறும் FCFSனா கன்ஃபியூஸ் ஆகாதீங்க. first come first served scheduling. Here, so this is one example for the first come first served scheduling. So these are all the processes, so names P1, P2, P3, and the burst time are these. Burst time is nothing but the time required for the process to complete. Okay, burst time is nothing but the time taken by a process for the completion. So suppose the processes arrive in the order P1, P2, P3. The Gantt chart for the schedule is, so this is called as the Gantt chart. Okay, so here in this chart we are mentioning the process names as well as the scheduling time. So processing time. Here, so since these processes are coming in this order P1, P2, P3, we are so executing this processing in processes in the same order like that. So since this P1 is taking the 24 seconds, so it will start from 0th second to 24 seconds. It will complete this process. And the P2 will come. So P2, it needs only 3 seconds. So from 24, it will execute process for the 3 seconds. So up to 27, it will execute. And but after, so from 27 and P3, but also needs 3 seconds. So that is why 27 to 30. Okay. So waiting time for P1 is so only 0 seconds. But for the P2 has to wait up to 24 seconds now. So that is why the P2 is equal to 24, and for the P3 it is equal to 27. So here our but average waiting time is what? 0 plus 24 plus 27 by the number of processes. So since we are having 3 processes, 3 which is equal to 70 seconds. Okay, so this is the first come first served scheduling. Whichever processes are first coming, it will be executed first. Okay, so this is the average waiting time. So any doubts here, students?
No, ma'am.
No. Okay.
No, ma'am, it's clear.
And second is, suppose that the processes arrive in this order. So in the previous slide, it comes in this order P1, P2 and P3. But if suppose but order is like this, P2, P3 and P1, the Gantt chart, the corresponding Gantt chart will be like this. So since P2 is coming first, so what is the burst time for the P2? It is 3 only. For P3 also it is 3, and P1 only it is 24. So here P2, since P2 is coming first, it will be served first. So 0 to 3, and P3 is coming next. So 3 to 6, and so P1 is coming at the last. So 6 to, so since it is taking 24 seconds, so 6 to 30. So here also we are calculating the waiting time like so for the P1, it will be 6 seconds for the waiting time. For the P2 it is only 0 and for the P3 it is only 3. So average waiting time is 0, 6 plus, so 0 plus 3, which comes around 3. So which is better here? Which is better here, previous one or the next one? So see the waiting time here, average waiting time, which comes around 70. But here the waiting time is only 3.
3 seconds.
Okay. So this is the better one. Okay. So much better than the previous case. This is called as the convoy that effect. So what do you mean by convoy effect is, we have to place the long process should be placed behind the short process. The short processor should be behind the long processes. Okay, this is called as the convoy effect. And the second algorithm is the shortest job first scheduling. So first come first serve pattern, that is the first algorithm. And the next one is the shortest job first scheduling. Here associate with so each process the length of its, so next CPU burst. Now when the example soldier that it will be understandable to you. So here, so SJ that is the shortest job first is optimal. It gives minimum average waiting time for a given set of processes. For example, here, so these are all the processes and these are all the arrival time and these are all the burst time. Burst time, as I said already, the process execution time. Okay. Here shortest job scheduling chart is here. They will first see the burst time, which process will take very less time. So here, but among these processes, the P4 is so having the very less burst time. That is why the P4 will be executed first. And but after the P4, the P1 is so having the very less time. So in the ascending order, the P1 will be executed next, and then the P3 will be executed, and then the P2 will be executed here. So according to this, the waiting time will be so change it here. So for the P4, so since it is only 0 to 3, and for the P1 it is having 6 seconds. So from 3 to 9, and for the P3 it is around 7. So 9 to 16 and 16 to 24. So here also the average waiting time, it should be calculated like this. We should take from here, not from here. 0, 3, 9, 16. We should not include the last time. Okay. So whenever we are calculating the average waiting time, we should take from the first. We should we should not take this time. Okay. So this is the shortest job first scheduling. Students, are you able to understand the first come first serve and the shortest job first scheduling?
Yes. Yes, ma'am. Understood.
Yes, ma'am.
Okay. So these are all, so totally I said totally, so 6 scheduling algorithms are there. So the first one is first come first serve and the shortest job first, second. And the third one is the priority scheduling. What is the priority scheduling is by the name itself, according to the priority, the scheduling will be there. A priority number is associated with so each process. So the CPU is allocated to the process with the highest priority. So here the highest priority is nothing but the smallest integer indicates the highest priority. So here preemptive and the non-preemptive. What do you mean by preemptive and non-preemptive is? Okay. So preemptive is nothing but whenever a process, so whether it completes its execution or not, it gives its control of that CPU control to the next process. That is called as the preemptive. So preemptive means what? Whether a process complete its execution or not, it give its CPU control to the next process is called as the preemptive. But automatically it will give its CPU time to the next process. That is called as the preemptive. And the non-preemptive is nothing but So so whenever a process is so executing, it won't give its CPU time to the next process. It will complete its execution completely, and then only it will give the CPU time to the next process, is called as the non-preemptive. Students, I hope you understand the difference between the preemptive and the non-preemptive.
Yes, ma'am.
Yes or no? So preemptive na enna? அது முடிக்குதோ முடியலையோ அது வேலையா நெக்ஸ்ட் ப்ராசஸ் வெயிட்ல இருந்தா ஒரு டயத்துக்கு மேல அந்த சிபியூ டைம் நெக்ஸ்ட் ப்ராசஸ்க்கு அது அலோகேட் பண்ணும். அதாவது ஆட்டோமேட்டிக்கா எனக்கு வேலை முடியுதோ இல்லையோ நான் உனக்கு தரேன் அப்படிங்கிற மாதிரி. பட் நான் ப்ரீஎம்டிவ்ல என்ன ஆகும், வேற நீ எவ்வளவு வேணும், சோ வாட் எவர் மே பி தி டைம்,
எவ்வளவு நேரம் ஆனாலும்
நான் என் ஒர்க்கை முடிச்சிட்டு தான் நெக்ஸ்ட் ப்ராசஸ்க்கு நான் தருவேன் அப்படிங்கிறது நான் ப்ரீஎம்டிவ். ஓகே. So SJF is a priority scheduling where priority is the predicted next CPU burst time. So okay, இங்க ப்ராப்ளம் நம்ம அப்புறம் பார்ப்போம். ஃபர்ஸ்ட் one second. இங்க என்ன ப்ராப்ளம் இஸ் priority scheduling தெரியுதுன்னா உங்களுக்கு ஹையஸ்ட் priority உள்ளது ஃபர்ஸ்ட் எக்ஸிக்யூட் ஆயிட்டே இருக்கும். இதுல இங்க என்ன ப்ராப்ளம்னு பாத்தீங்கன்னா, ப்ராப்ளம் இஸ் a starvation. So what do you mean by starvation? But always the low priority processes may never execute. எப்பவுமே highest priority execute ஆயிட்டே இருக்கறனால என்ன ஆகும், low priority processes may never execute. And also so what is the solution for this? That is the aging. So what do you mean by aging? As a time progresses, இப்போ for example 10 processes இருக்குன்னு வெச்சுக்கோங்க. So 10 processல only 5 process or so 6 processக்கு highest priority கொடுக்கறோம்னா மாறி மாறி இது எல்லாமே எக்ஸிக்யூட் ஆயிட்டு இருக்கும். அந்த லாஸ்ட் 4 ப்ராசஸ் எக்ஸிக்யூட் ஆகாது. சோ அப்ப அந்த லாஸ்ட் ப்ராசஸ் எப்பதான் எக்ஸிக்யூட் ஆகுது, அது ஒரு ப்ராப்ளம். தட் இஸ் கால்ட் as a starvation. So in order to solve the solution or the problem, in order to solve the problem, we have one idea called the aging. What do you mean by aging is, as the time progresses, we will wait for some time, and then after that only we have to increase the priority of the processes. We have to change the priority of the process, but in order to execute. Okay, so this is one solution for the starvation problem. Students, I hope you understand the starvation and the aging concept.
Yeah, ma'am. Sure, ma'am.
Yes?
Yeah.
Yes, ma'am.
So this is the third type of scheduling algorithm. Okay, priority scheduling. First one is first come first serve and shortest job first and priority scheduling. So what is the problem in priority scheduling is starvation, and the solution for starvation is the aging process.
Ma'am, can I explain aging once again?
Okay. So aging is nothing but starvation. You understand starvation. You understand the problem of starvation.
Yes, ma'am.
Yes, no? Okay,
yes.
Aging is nothing but we will wait for some time for the low priority marked processes to execute. If suppose the low priority processes are not executing for the long time, we should change the priority of the low priority processes so that it may, but also it should be executed. இப்போ ஃபார் எக்ஸாம்பிள் நான் சொன்னேன் இல்லையா, அவுட் ஆஃப் 10 ப்ராசஸஸ் லாஸ்ட் 4 ப்ராசஸஸ் லோ ப்ரியாரிட்டி இருந்தா இட் வில் வெயிட் ஃபார் வெரி லாங் டைம். அந்த லோ ப்ரியாரிட்டியும் எக்ஸிக்யூட் ஆகிறதுக்காக என்ன பண்ணுவோம், அந்த 6th or 7th உள்ளத செகண்டாவோ இல்லாட்டி 8th உள்ளத தேர்டாவோ, அது மாதிரி we have to change the priority of the processes so that it should be also execute. Yes,
We are changing the priority after sometimes, right?
Yes.
Depending upon the waiting time.
Depending upon the waiting time. அதாவது ரொம்ப நேரம் வெயிட் பண்ணுதா இல்லையான்னு செக் பண்ணணும். இப்ப சில நேரத்துல பாத்தீங்கன்னா இப்ப ப்ராசஸஸ் ஃபார் எக்ஸாம்பிள் ப்ராசஸஸ் 10னா 10ஆவே இருக்காது. அது ப்ராசஸஸ் கீப் ஆன் கம்மிங் டு த ப்ராசஸர். நோ, இப்ப ப்ராசஸஸ் கீப் ஆன் கம்மிங் டு த ப்ராசஸர். வெறும் ஹை ப்ரியாரிட்டி இதுவே அது எக்ஸிக்யூட் பண்ணிட்டு தான் லோ ப்ரியாரிட்டி எப்பதான் எக்ஸிக்யூட் ஆகுது. So it will wait for some time and then only it will change the priority of the process so that the low priority processes will also execute after some time. That is called as the aging process. Hope you understand, student.
Yes, ma'am. Understand.
Yes? Okay.
Yes, ma'am.
Okay, this is the third type of scheduling. And the fourth type is so round robin. So this is an interesting scheduling algorithm. So each process so gets a small unit of CPU time. So usually, for example, 10 to 100 milliseconds. After this time has so elapsed, the process is preempted and but added to the end of the ready queue. So I hope you but understand the concept of preemptive and non-preemptive. Okay. So so with the example, I will so explain the round robin. Here, so this is one example. These are all the processes and these are all the burst time. So the Gantt chart here is, so for the round robin scheduling algorithm, always it will be given with the time quantum. Okay, time quantum which is equal to 4 seconds. Here, the Gantt chart should be like this. For the P1, so though it is having the execution time or the burst time as the 24, so since the quantum time is only 4, it will first process for the first 4 seconds. And preemptively, it should so give the processor to the so CPU to the P2. So since P2 is having only 3 seconds, it will execute for the 3 seconds. And the processor will come to the P3. And for P3 also the 3 seconds is there, so it will 3 seconds. And P1. So again, so but after P3 no more processes are there, so it again come to the P1. So P1, so since the so time quantum is equal to 4, it will but again execute for the 4 seconds. And P2 P3 already completed, so it will again so execute for the 4 seconds 4 seconds 4 seconds up to 24 seconds. So inge over 4 seconds inge parunga, so 8 and 12 60 20 24. Students, I hope you understand this. So Gantt chart.
I can't understand.
Excuse me, any doubts in this so Gantt chart?
Can you explain again?
Yes. So here, what you mean by round robin is nothing but, so in the round robin, your time quantum will be there. So for our example, the time quantum is equal to 4 seconds. So it will first take the process 1. So process 1 will be so executed for the 4 seconds. And but after 4 seconds, automatically the processor will also go to the process 2. Here the P2 is having totally 3 seconds for the execution. So it will so execute for the 3 seconds. So 4 to 7. And but again the processor will come to P3. So P3 is also having the total time of 3 seconds. So P3 will execute for the 3 seconds. So 7 to 10. And so here P2 is completed, P3 is completed. So only P1 is there. So again the processor will go to P1. So P1, so since it is having totally 24, it has completed but already so 4 seconds only. So since the time quantum is 4 seconds, here again they will so execute for the 4 seconds. It will wait for the next process. So whether so any other process is coming or not. If so there are no processes, so again and again the P1 will be executed. Okay, if suppose so in between, so any other processes are come, for example P4, so P5, the processor time will be allocated to the P4. Students, so புரியுதா இது என்ன ரவுண்ட் ராபின்ல?
புரியுது மேம்.
So இப்ப புரியுதா? அதாவது நம்ம ஃபர்ஸ்ட் P1 வந்து 4 செகண்ட்ஸ்க்கு so எதனால 4 செகண்ட்ஸ் தான் இங்க எக்ஸிக்யூட் ஆகுதுன்னா because the time quantum is equal to 4. So according to the time quantum it will be executed. So next P2 it will automatically
it will execute 20 and after the circle it will get 4 gets replied ma'am.
One second கேளுங்கப்பா, உங்களோட வாய்ஸ் பிரேக் ஆகுது, சொல்லுங்க.
Yeah, if the time quantum is 20 seconds means if it will execute 20 and after the 4 will be in this number.
Yes. So that's the concept. According to the time quantum it will execute. இப்போ உங்களுக்கு இங்க 4 இருக்கு, பட் இதோட டோட்டல் ப்ராசஸ் டைமே 3 இருக்கனால 3 ஓட முடிச்சுக்கும் அதோட வேலையை. So round robin so scheduling algorithm so it's a preemptive scheduling algorithm. ஸோ புரியுதா இப்போ உங்களுக்கு ப்ரீஎம்டிவ்னா என்னென்ன? ஸோ ரவுண்ட் ராபின் இஸ் a preemptive scheduling algorithm. இது மாதிரி உங்களுக்கு வந்து கிளாசிஃபை பண்ண தெரியணும், எந்த ஷெட்யூலிங் அல்காரிதம் ப்ரீஎம்டிவ், எந்த ஷெட்யூலிங் அல்காரிதம் வந்து நான் ப்ரீஎம்டிவ் அல்காரிதம். சரியா? ஸோ இப்போ நீங்க முன்னாடி பாத்தீங்கன்னா ஃபர்ஸ்ட் கம் ஃபர்ஸ்ட் சர்வ்லாம் பாத்தீங்கன்னா நான் ப்ரீஎம்டிவ், அது மாதிரி தான் ஷார்டஸ்ட் ஜாப் ஃபர்ஸ்டும், அப்படிதானே?
எஸ் மேம்.
ஸோ ரவுண்ட் ராபின் மட்டும்தான் உங்களுக்கு ப்ரீஎம்டிவ் ஷெட்யூலிங் அல்காரிதம். முடிக்குதோ இல்லையோ அந்த 4 செகண்ட்ஸ்க்கு அப்புறம் நெக்ஸ்ட் ப்ராசஸருக்கு அதோட இது போயிடும், அதோட கண்ட்ரோல் போயிடும். சரியா? ஸோ திஸ் இஸ் அ ரவுண்ட் ராபின் ஷெட்யூலிங் அல்காரிதம். So shall I go to the next scheduling algorithm?
Yes, ma'am. Yes, ma'am.
Okay. யாரோ டிராவல் பண்ணிட்டே கிளாஸ் அட்டெண்ட் பண்றாங்க போல. So multi-level queue. So ready queue is partitioned into separate queues. So multi-level queues is nothing but, so here, so see here, multi-level queue scheduling. So here, okay, ready queue is partitioned into 2 separate queues. So foreground and so background. Okay, so in the multi-level queue they will separate the types of processes into 2 types. So foreground queue and the so background processes. So each queue has its own scheduling algorithm. So foreground will use the round robin algorithm and the background processes will be used the first come first serve algorithm. So எது வேணாலும் யூஸ் பண்ணிக்கலாம். நான் இப்போ எக்ஸாம்பிளுக்கு ரவுண்ட் ராபின் அண்ட் ஃபர்ஸ்ட் கம் ஃபர்ஸ்ட் சர்வ் சொல்றேன். ஸோ எந்த டைப் ஆஃப் அல்காரிதம் வேணாலும் அதை வந்து யூஸ் பண்ணிக்கலாம். ஷெட்யூலிங் மஸ்ட் பி டன் பிட்வீன் த கியூஸ், ஃபிக்ஸ்டு ப்ரியாரிட்டி ஷெட்யூலிங் அண்ட் டைம் ஸ்லைஸ். இங்க பாருங்க. So each queue gets a certain amount of CPU time which it can schedule among its processes. That is the 80% to foreground in the round robin and 20% to background. அதாவது இங்க இந்த multi-level queueல 80% of the CPU time will be go to the highest priority of the foreground processes, and only 20% of the CPU time will be allocated to the background processes. Okay, so this is the concept here. Here, so in the multi-level queue scheduling, the first step is what? They will divide the processes into 2 queues. First one is the foreground queue and the background queue. And so both the foreground and the background queue will utilize the different scheduling algorithms. And so 80% of the CPU time will be allocated to the foreground queues, and the 20% of the CPU time will be allocated to the background queues. So this is the concept here. So they won't change the queue here. So what do you mean by they won't change the queue here? For example, இப்போ எனக்கு வந்து lowest priority இருக்கு, highest priority இருக்கு. அந்த highest priorityல system process இருக்கு, interactive processes இருக்கு, இதெல்லாம் இருக்கு. I can't change the priority of the process here. The student process, that we can't change the priority of the student process as the highest priority, and also we can't change the system process as the lowest priority here. This is the concept of the multi-level queue schedule. Students, புரியுதா?
Yes, ma'am.
Yes? Yes, ma'am. Okay. And this is the 5th type of scheduling algorithm. Okay, multi-level queue scheduling. And the last one is the multi-level feedback queue. What do you mean by multi-level feedback queue is a process can move between the various queues. So aging can be implemented this way. So in the previous scheduling algorithm, what I told you, the highest priority process cannot be changed as a lowest priority, and the lowest priority cannot be changed as a highest priority process. But here, in the multi-level feedback queue, we can change the priority of a process. That's why that is called as the aging now, as I already told you. So aging can be implemented this way, and the multi-level feedback queue scheduler defined by the following parameters. Okay, so here in the multi-level queue, we can change the priority of so process. So here multi-level feedback queue scheduler defined by the following parameters: number of queues and scheduling algorithms for so each queue. The method used to determine when to upgrade a process and when to degrade a process, and method used to determine which queue a process will enter when that process needs the service. அதாவது இந்த டீடைல்ஸ் எல்லாமே மல்டி லெவல் ஃபீட்பேக் வந்து ஷெட்யூலிங் அல்காரிதத்துல இருக்கும். So so when we can upgrade a process, when we can so demote a process, so like that it will tell you. So example of multi-level queue பாருங்க இங்க. So these are all the queues. Okay, here so one process is allotting so quantum time of the 8. Okay, so 8 but first if suppose consider this process requires totally 32 seconds, but since it is allocating in the first time, so since it is allocating only 8 seconds, this process will be allocated or changed to the next priority. So here the quantum is equal to 16. But again, since the total execution time is equal to 32, it won't complete the execution. So execution, that is why it is a, so it again comes to the first come first serve basis. So here, so what is the first come first serve basis? It is a non-preemptive scheduling algorithm. So 16 plus so 8 is 24. So 24, so balance is so 8. So remaining so 8 seconds will be so executed with the help of the first come first serve scheduling algorithm here. Okay, so this is how we can change the priority of a process in the type of multi-level feedback queue scheduling algorithm. Students, are you able to understand this so example?
Yes,
Shall I
ma'am.
once again repeat?
Again? Yes, ma'am.
Okay.
Repeat, ma'am.
Okay, so consider one process, so total that burst time, that is the execution time is equal to 32 seconds. Okay, consider a process requires totally 32 seconds for its to complete its execution. Here the process is so enter into the first queue, so where it has been allotted only 8 seconds. Okay, but its total seconds is what? It is 32 seconds it requires. So at first it so execute for so 8 seconds. So since it is not completed, it again the priority will come to the second, so highest priority. Here, so in this also the quantum time is equal to 16, but already it has been executed for the 8 seconds, and the second time it has been executed for the 16 seconds. So totally that particular process has completed totally 24 seconds of its so execution time. Okay, so so what is the remaining time for the process? So 32 minus 24 is so 8 seconds, no? So in order to complete this process execution, it again the process priority will be come to the third level, and it will so use this first come first serve priority scheduling priority first come first serve scheduling algorithm, where it is a non-preemptive. So totally it will complete its so execution in the first come first serve, so in this priority level, and it will come out. புரியுதா? again explain பண்ணுமா?
Yes, ma'am. Clear, ma'am.
புரியுதா?
Clear, ma'am. Yes, ma'am.
Then what is the main difference between multi-level queue and multi-level feedback? So in the multi-level queue, again இவ்வளோ what is the main difference between multi-level and so multi-level queue is we can't change the priority here, but in the multi-level so feedback queue we can change the priority. So that's the main difference between multi-level queue and multi-level so feedback queues algorithm. Students, are you able to understand the difference here?
Yes, ma'am.
Yes, ma'am.
So these are all the scheduling, that is the CPU scheduling algorithms. First one is first come So from the first, I told you what are the scheduling criteria now. So throughput and what is the turnaround once again. So CPU utilization, throughput and the turnaround time, waiting time and the response time. These are all the scheduling criteria, and so these are all the types of scheduling algorithms. First come, first serve, shortest job first, and the third one is the priority scheduling, and the fourth one is the round robin, multi-level queue and multi-level, so feedback queue. So any doubts in this scheduling algorithm, students? Okay. Shall we pass on to the next concept?
Sure, ma'am.
Okay. Students, next we come to the concept called the threads. So what do you mean by a thread is an execution unit which consists of its own program counter, a stack and a set of register is called as a thread. Thread is nothing but அதாவது நீங்க ப்ராசஸ்னா என்னன்னு கேட்கலாம். ப்ராசஸும் எக்ஸிகியூஷன் யூனிட் தான், த்ரெட்டும் எக்ஸிகியூஷன் யூனிட் தான். So then what is the difference between a process and a thread? Process and thread பாத்தீங்கன்னா ப்ராசஸ்ல உள்ள ஒரு யூனிட் தான் த்ரெட். சரியா? அந்த ப்ராசஸ நம்ம செவரல் டிவிஷன் பண்ணோம்னா அதுதான் த்ரெட். ஸோ த்ரெட் இஸ் a small execution unit which consists of its own program counter, a stack and a set of registers. And threads are also known as the lightweight processes. Okay. So threads are popular way to improve the application through parallelism. So that's what I told. A process, so whenever a process is divided into so many pieces, that is called as a thread. Here, what is the necessary to divide the processes? In order to attain the parallelism or parallel or concurrent execution, we are dividing the process into so many threads. So here the threads are called as the lightweight processes, and it consists of its own program counter, a stack and a set of registers. The CPU switches rapidly back and forth among the threads, so giving illusion that the threads are running in parallel. Okay, so these are all some of the types of thread. So single threaded process and multi-threaded process. So this is a so only one thread is executed in a only one thread is there in a process, and this is a multi-threaded process. So here a particular process is divided into 3 threads, and each and every threads are having the this register, stack and code, data files, etc. And so there are 2 types of threads. The first one is the user thread and the kernel threads. What do you mean by user threads are? So user threads are above the kernel and without the kernel support. Okay, so these are the threads that application programmer use in their programs. உங்களுக்கு application programனா என்ன? So they don't know inside what is the software, what are the coding part they don't know, and they don't have any connection with the kernel at all. Just they will utilize the application. For example, இப்போ நம்ம ஒரு சென்னை சிப்ஸோ ஏதோ மெப்ளஸ் போனோம்னா only they will ஒரு அப்ளிகேஷன் டெவலப் பண்ணி கொடுத்துருவாங்க, அதை மட்டும் தான் அவங்க யூஸ் பண்ணுவாங்க. they don't know anything about the coding at all. That is called as the user threads, and the kernel threads are supported within the kernel of the OS itself. So but all modern OS support the kernel level threads, allowing the kernel to perform the multiple simultaneous tasks. and to service the multiple kernel systems. So kernel threads என்ன பண்ணும், அதுதான் OS ஓட இன்டராக்ட் பண்ணும். சரியா இன்டராக்ட் பண்ணி ஸோ நம்ம என்னென்ன சேஞ்சஸ்லாம் பண்றோமோ அதுக்கு ஏற்ற மாதிரி அது அப்ளிகேஷனை சேஞ்ச் பண்ணும். தட் இஸ் கால்ட் அஸ் த கர்னல் த்ரெட்ஸ் அண்ட் த யூசர் த்ரெட்ஸ். அண்ட் ஸோ 2 types சொன்னேன் இல்லையா, சிங்கிள் த்ரெட்டட் அண்ட் மல்டி த்ரெட்டட் ப்ராசஸ்ங்க. இங்க வந்து மல்டி த்ரெட்டட் ப்ராசஸ் இட் அகெயின் கிளாசிஃபைட் இன்டு 3 types, 1-to-1 model and the 1-to-1. The user threads must be mapped to the kernel threads by one of the following strategies. So many to one model, 1-to-1 model and the many to many model. Okay, so what do you mean by many to one model? By the name itself we know, so many user threads can be mapped to only one kernel thread. So this kernel thread will control these 4 threads. Okay, and 1-to-1 model, so one thread is controlled by one kernel. So each and every kernel is called as the 1-to-1 model. And many to many model, so many users will be controlled by the many kernels. That is called as the many to many model. So these are all the theory part that you can study by yourself. Okay, so what are the thread libraries and benefits of multi-threading and all. Okay, so I won't okay, so these are all about the threads. So till now any doubts for you? No. Okay. Okay, but I hope so today's class is so we can complete up to this, because so many concepts are there. I will take slowly only. I won't so rush up you as well as me. Okay, உங்களுக்கு வந்து ஒரே டைப் எல்லா கான்செப்ட் எடுத்தா ஒண்ணுமே புரியாது. ஸோ நான் உங்களுக்கு வந்து இன்னைக்கு கிளாஸ்க்கு இதோட போதும், இந்த ஸ்டெப்போட போதும். நான் உங்களுக்கு ஐ வில் சென்ட் யூ த நோட்ஸ். ஓகே ஸ்டூடெண்ட்ஸ்?
Okay, thank you, ma'am.
So by tomorrow we yes
ma'am, exam வந்து
ஆன்லைன்
எக்ஸாம் வந்து ஆன்லைனுக்கு ரெகுலர் ஸ்டூடெண்ட்க்குலாம் ஆன்லைன்ல நடக்குது மேம்.
இல்லையே, ரெகுலருக்குமே ஆஃப்லைன். ஆமா, எஸ் ஆன்லைன்ல தான் நடக்குது.
அப்போ எங்களுக்கு ஆன்லைனா ஆஃப்லைனா மேம்?
இல்லம்மா, உங்களுக்கும் ஆன்லைன் தான் நடக்கும்.
எஸ் மேம், அதான் மேம் லாஸ்ட் நீங்க ஆஃப்லைன் சொன்ன மாதிரி இருந்தது மேம். சோ தட் அந்த டவுட்டுக்காக தான் மேம் கேட்டேன்.
இல்ல லாஸ்ட் டைம் ஆஃப்லைன் சொல்லியிருப்பேன், பட் அது எல்லாமே யுனிவர்சிட்டி டெசிஷன் தானே. நான் அவங்க சொன்னா நான் சொல்ல முடியாது இல்லையா?
எஸ் மேம், ஓகே மேம்,
தேங்க்ஸ். ரெகுலருக்கு ஆஃப்லைன் தானே சொல்லியிருந்தாங்க.
எஸ் மேம். இல்ல மேம், என்னுடைய பிரதர் தான் இங்க ஆன்லைன்ல தான் மேம் அட்டென்ட் பண்றாங்க. நியூ காலேஜ்ல தான் என்னுடைய பிரதர் படிக்கிறாரு. அவர்லாம் ஆன்லைன்ல தான் எக்ஸாம் வந்து ஸ்டார்ட் ஆகி அவங்களுக்கு 2 பேப்பர் கிட்ட முடிஞ்சிருச்சு மேம். சோ அதனால தான் கேட்டேன் மேம்.
ஓகே, ரெகுலர்ல பண்றாரா?
எஸ் மேம், நியூ காலேஜ் மேம்.
ஓகே ஃபைன். சரி ஓகே.
எக்ஸாம் போடல.
எக்ஸாம் எப்போ முடியுது? நம்ம எக்ஸாம் எப்போ முடியுது?
எக்ஸாம் உங்களுக்கு இப்பதானே கிளாஸஸ் ஆரம்பிச்சிருக்கு. ஸோ தே வில் ஆல்சோ ஓபன் யூ த போர்ட்டல் பை நெக்ஸ்ட் வீக். ஐ ஹோப் ஸோ. அதுல இன்டிமேஷன் வந்திருக்கல உங்களுக்கு வெப்சைட்ல?
செகண்ட் வீக்
வந்திருக்கு இல்லையா?
February 2nd week.
எஸ், உங்களுக்கு மோஸ்ட் ப்ராபபிலி ஆஃப்டர் March 15th இருக்கலாம், அப்ராக்சிமேட்லி சொல்றேன்.
Okay ma'am, thank you ma'am. Okay
மேம், இந்த கிளாஸோட ஓவரா நெக்ஸ்ட் கிளாஸ் இருக்கா மேம்?
நெக்ஸ்ட் கிளாஸ் நாளைக்கு போட்டுருவோமேப்பா.
இல்ல மேம், இன்னைக்கு 2 கிளாஸ் போட்டுருந்த மாதிரி இருந்தது மேம். சோ அதனால கேட்டேன் மேம். இதோட ஓவர்ல மேம்?
ஆமா, இதோட ஓவர் தான். ஏன்னா நான் I don't want to so stuff you students.
எஸ் மேம், தேங்க்ஸ் மேம்.
So that's why I so leave you by 4:40. Okay.
The questions in
what about practicals ma'am?
What about practicals? Since your so exams are on but online, there won't be any physical classes for you practicals, for your practicals.
Practicals ஆன்லைன்ல தான மேம் இருக்கும். ஓகே மேம்,
practicals உங்களுக்கு ஆன்லைன்ல தான் இருக்கும். ஆன்லைன் இந்த சென்ஸ் இப்ப பிசிக்கலா நம்ம பண்ணும்போது நீங்க இங்க வந்து லேப்ல வந்து எக்ஸிக்யூட் பண்ணி எல்லாம் பண்ணுவீங்க, ப்ரோக்ராம் எழுதி எக்ஸிக்யூட்லாம் பண்ணுவீங்க. பட் so since it is a but online process that you won't come to the lab, so like your theory papers that you will write your practical exams are also through online.
What are the important topics in this subject? Can you please send me the PPT?
Yes, so definitely I will send you the PPT. I hope all of you are in your group.
மேம் பிபிடில நிறைய டாபிக்ஸ் இருக்கு, ஏதாவது ஸ்பெசிஃபிக் டாபிக்ஸ் இருக்கா மேம்? லைக் ஃபோக்கஸ் பண்ணி பார்க்கணுன்ற மாதிரி தான்.
ஓஎஸ்லயா?
எஸ் மேம்.
இப்ப நான் நடத்துறது எல்லாமே நான் ஃபோக்கஸ் பண்ணி தான் நடத்துறேன். நான் எல்லாத்தையுமே அதாவது நான் இந்த சென்ஸ் உங்களுக்கு வந்து யூனிட் வைஸ் தான் நடத்துறேன். ஸோ வாட் ஆல் த டாபிக்ஸ் நான் உங்களுக்கு கவர் பண்ணி நடத்துறேனோ அதை மட்டும் இது பார்த்தாலே போதும் உங்களுக்கு.
ஓகே.
ஃபார் எக்ஸாம்பிள் நான் உங்களுக்கு வந்து ஷெட்யூலிங் அல்காரிதம் சொன்னேன் இல்லையா?
எஸ் மேம்.
எஸ், ஷெட்யூலிங் அல்காரிதம் இந்த த்ரெட்ஸ் இனிமே
எக்ஸாம் எப்போ ஸ்டார்ட் ஆகுதுன்னு ஐடியா இருக்கா மேம்?
புரியலமா?
எக்ஸாம் எப்போ ஸ்டார்ட் ஆகுதுன்னு ஐடியா இருக்குமா மேம்?
அதான் சொன்னேன், செகண்ட் வீக் ஆஃப் மார்ச்ல உங்களுக்கு வர சான்ஸ் இருக்கு.
ஓகே ஓகே, தேங்க் யூ மேம்.
மேம் ஐ couldn't.
மேம் இன்டர்னல் எக்ஸாம் எப்படி மேம் இருக்கும்?
இன்டர்னல் எக்ஸாம்ஸ் உங்களுக்கு வந்து MCQஸா இருக்கும், பட் ஆன்லைன்ல தான்.
அது இல்ல டேட் அந்த மாதிரி எப்படி மேம் இருக்கும்? முன்னாடியே இருப்பாங்க.
அது நீங்க எல்லாம் வந்து once you enrolled in the Madras University, that is the Institute of Distance Education, you have to watch your website daily. Okay, so உங்களுக்கு so எல்லா அனௌன்ஸ்மென்ட்டும் உங்களுக்கு வெப்சைட்ல தான் வரும். So they will give you a specific time gap for completing the internal assessment. Okay
மேம்.
So MCQs are objective type questions.
ஆன்லைன் எக்ஸாம்னா எப்படி மல்டிபிள் சாய்ஸ் क्वेश्चंस மாதிரி இருக்குமா மேம்?
இல்ல உங்களுக்கு எல்லாமே எழுதி அனுப்புறாங்க. உங்களோட பிசிக்கல்ல எப்படி எழுதுவீங்களோ 3 hours அது மாதிரி தான் இருக்கும்.
மேம் கொஞ்சம் அட்டெண்டன்ஸ் பத்தி கொஞ்சம் சொல்லுங்க மேம்.
அட்டெண்டன்ஸ் சோ அத சொல்றேன் ஃபர்ஸ்ட். So whenever you are entering into the class, so உங்களை கேக்கும்ல நேம் என்னன்னு சொல்லி. So just to enter your roll number, so more than rather than your name, so that I will download the attendance.
Sure.
மேம் நாங்க சாட் பாக்ஸ்ல எல்லாரும் நேம் மென்ஷன் பண்ணி ரோல் நம்பர் மென்ஷன் பண்ணி போட்டுறோம் மேம். இதனா ஃபார் தட் மேம்.
சாட் பாக்ஸும் ஓகே, பட் எனக்கு நீங்க இங்கேயே போட்டீங்கன்னா இது எனக்கு ஒரு எக்ஸல் ஷீட்டா வந்துரும்.
இப்போ நம்ம
இல்ல நீங்க வந்து இப்ப இன்னைக்கு கிளாஸ் விட்டுருங்க, நாளையில இருந்து அது மாதிரி பண்ணுங்க. பட் சாட் பாக்ஸ் போட்டாலும் அதுவும் we can collect from the chat box, பட் இது வந்து ஆட்டோமேட்டிக்கா எங்களுக்கு ஒரு எக்ஸல் ஷீட்டாவே டவுன்லோட் ஆயிடும்.
எனி ப்ராப்ளம்
டெஸ்க்டாப் யூஸ் பண்றவங்களுக்கு சாட் பாக்ஸ்
அதெல்லாம் ஒண்ணாகாது.
பெட்டரா டெஸ்க்டாப்ல யூஸ் பண்றவங்களுக்கு சாட் பாக்ஸ் ஆப்ஷனே கிடையாது மேம். எனக்குலாம் காட்ட மாட்டேங்குது சாட் பாக்ஸ். சோ நீங்க இப்படி டவுன்லோட் பண்றது கரெக்ட்டா இருக்கும் மேம்.
சரி ஓகே ஃபைன். சரி
மேம்
எங்களுக்கு அந்த மாதிரி ஆப்ஷன்ஸ்
மேம் ரீநேம் எனேபிள் பண்ணா இங்கேயே கூட பண்ணிடலாம் மேம். ப்ளீஸ் எனேபிள் ரீநேம் மேம்.
எனேபிள் ரீநேம் சரி ஓகே நான் பண்ணிடுறேன்.
மேம் C++ம் அக்கவுண்ட்ஸ் கிளாஸும் நெட் வச்சு லாகின் பண்ணவங்களுக்குலாம் எப்படி மேம்?
நான் C++ம்
அக்கவுண்ட்ஸ் கிளாஸ்க்கும் நான் வச்சு லாகின் பண்ணி இருந்தேன் மேம். நீங்க இன்னைக்கு சொன்ன உடனே நான் வந்து இன்னைக்கு தான் ரோல் நம்பர் போட்டு இது லாகின் பண்ணியிருக்கேன். அப்ப அந்த 2 கிளாஸ்க்கு அட்டெண்டன்ஸ் எப்படி இருக்கும் மேம்?
அதுக்கு வந்து உங்களோட நேம் வச்சு பண்ணிருக்கீங்களா?
ஆமா.
சரிம்மா, அது ஸோ தே வில் டவுன்லோட் அவங்க ஆல்ரெடி இப்போ இந்த அட்டெண்டன்ஸ் வந்து எக்ஸல் ஷீட்டை டவுன்லோட் பண்ணியிருப்பாங்க. ஸோ நாங்கள் வந்து ஃபில்டர் பண்ணும்போது உங்கள் நேம் எல்லா இதுலேயும் இருந்தால் உங்களோட அட்டெண்டன்ஸ் இருக்கும், அவ்வளோதான்.
இல்ல என் நம்பர் அனுப்பணுமா மேம்?
இல்ல சேட் அனுப்பிருக்கீங்களா? சேட் பாக்ஸ்ல போட்டிருக்கீங்களா?
மேம் ஸ்டார்டிங்ல எல்லா கிளாஸுக்குமே வந்து வெறும் சாட் பாக்ஸ்ல தான் மேம் நாங்க எல்லாருமே